momentarily saying that we're streaming live. I know I still got to update like my headers for the other time. I just had to label things properly and kind of do some video editing. I'm just putting the raw files there and making it available. So I just got the notification. You should have just gotten it as well. So just click it, open it, make sure you can hear and see it. And I'll update those titles later. But yeah, somebody can verify that. So we did decide that we're gonna move exam one. Yeah, I can hear the audio, right? You can hear it. Yeah. Audio's good, and you can see it. The picture looks good. Yeah. Can I see it? Anybody got it? Yeah. Oh, I need to move. Let me move it to the hang it right there. Hang on. Let's go here, and I need to unlock it, which is the window capture. So I'll give it a little bit. I don't know what the delay is. It should be moved. No. It sounds like when you're right there. Oh, what are we going to do? Okay, that's fine. Or maybe it's just because I go full screen. I don't really know how to adjust for this. You know what? I'm going to let that be for right now because I think I did move it to the left and it did move it. So I think that's just how it's appearing when I go full screen, so I'm going to have to go with it for now. That's good enough. And I'll have to fix that later. Go ahead. I didn't tell you about Okay. So with that last page of the syllabus, you can load a digital copy. You don't have to print out a hard copy. Everybody should have their own individual folder. I send it to you in your email as an invite. Accept it, and so you have access to 2 box folders. One that has your name on it, and then the other one that's access to Moodle. But if you want to share any kind of documents or files, you're going to put it in your personal folder, and I'll be able to see it. Just make sure a copy is in your folder. It is, say, hey, Mr. Pfeiffer, I just want to confirm that you received my document. Go ahead. You can print it out. You can write it, and then snap a photo, and then load that photo into your document. You can definitely do it because I know just about everybody should be able to load a picture. Yeah, you use PDF editor. You can write it digitally. There are several ways to do it. So I just need something where you fill it out and you load it back and it's going to work. So the exam will be Tuesday. Tuesday, you need a number 2 pencil, regular calculator. You can use the graphing or scientific. That's fine with me. But no cell phone calculators, no tablet calculators, no smartwatches, no Google Glass, no smoke screens, no smoke signals, no sign language. Okay, no ESP. Okay, ESP is okay. You can use ESP if you have ESP. Extrasensory perception. If you have, that's the only thing I'll allow. Psychic. If you're a psychic, you can do that. but no. I couldn't even get a laptop. But no smart devices. Okay. But just a regular calculator, your number 2 pencil, and your completed homework notebook. Okay. I think Moodle is fine. I don't think there's anything there that we need to do. So let's open up the assignment. The notes for today. So I like the streaming. We need a copy. So we want to go to the blank file, which is here. We want to go to edit. Yeah. And we want chapter 2. Where's 2-1? Oh, 1, 2, 3, 4, 5, 6, 7, 8. And let's go ahead and go back to the blank page. We don't need to. Okay, we want to duplicate all this. It'd be nice if I can solely highlight the duplicates. It's okay. Then we're going to, this is the nice and huge. Oh, wait a minute. Let me go here really quickly. 2, 1, 2, 2. 3, 2, 4. So these blank files. So 2, 1. We just need one of these. So like this. Yeah, it should move. So 1, 2, 2. This one. 2, 3 is this one. 4 is this one. 5. 6. 7. And last but not least, 8. So we should have them all here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So then this is what this is length and hues, is that right? Mm-hmm. This is length and hues?
Yes.
Oh, unison, that looks great. I do. Something like that. Is that right? Is there an E? No E in there? Huh? I put E on everything? Yeah, my spelling is not the best. That's why I do. Hues. Is that right? Nope. That doesn't look right. 8. Is this good? Yeah. Hues. I think that's it. Okay. We want to copy this. I'll get that later. One other thing that I need before we get into it, I need to go to box. Is it working?
It says on mine, it just says perspective.
I want to share this. Export. I want to copy to this. Add to this note, but I don't want everything. I just want that one thing. Okay. Then that's right here. I'm going to copy this, and we're good to go. Alright. I gotta remember that when we get to that section. I'll remember when I get to that section. I did the math poem with you already, right? Math poems? Yeah. 12 plus 144, guys. Plus 3 times the square root of 4. I did that one, right? Okay. Okay. Yeah, that's the one I did with my earlier class. So I'll let that be for today. I can't think of anything else. I'll be talking to you. Alright. Keep in mind, this stuff picks up the audio. It picks up everything, so just kind of keep that in mind. Alright, so today we're going to be moving into section 2.1. Alright, rectangular coordinates and graphs. Now, when we're talking about rectangular coordinates, what we're talking about? The what axis and the what axis? X-axis, Y-axis, okay?
Yes.
Order pairs, I think are fine. Anybody know where does the distance formula come from offhand? What concept?
Just physics. It comes from physics. Kind of.
You'll see it. So I was just curious. I was just doing a quick poll of the audience. Oh, and this reminds me. Just remind me when we finish this section, I need to take a few minutes. Okay, so let's kind of keep going and see how it comes about. So ordered pairs consist of 2 components written inside parentheses. For instance, if we have this example, it says use the table to write ordered pairs. So for instance, what gets grouped with food? What amount?
6,400.
6443. That's okay, right? We do the next ordered pair with group with housing.
17,400.
That's straightforward, okay? So those are examples of ordered pairs. So if we're talking about what goes with housing, you have that ordered pair, so on and so on, okay? We have independent and dependent variables. I feel like you guys know this already. So I'm going to keep moving. So this is the coordinate plane of the Cartesian plane. The positive x-axis is this way. Let's see my drawing skills. Give what? Is that like green? Like this color?
There you go, teal right there.
This one? Yeah. Is it more green?
It's like, yeah, it's like a green.
Like this one?
Yeah, there you go.
Okay, so let's go with this one. So we got a color. Give me a random, something random.
A bunny.
Bunny. Alright, if I'm going to do a bunny, I don't know. I think bunny, I'm going like this. It's because they got the ears, right?
Yeah, it's so cute.
A little bit.
Yeah, you can draw.
And you know what? The bunny has a carrot in his mouth. It's a green bunny. I don't know why he's green. And he's eating carrot for some reason.
It's a cute bunny.
And there's the bunny with the carrot in it. And so this is going to be our pointer for right now. I want to copy. I'm going to go like this. And that's kind of huge, so what I'm going to do is shrink it down to size. Alright, copy it. So that's going to be our cursor for right now. And shrink it down just a little bit more. Okay. That's fine. So now, little bunny. Okay. So we have the XY plane. We have the coordinate plane. Positive X is going this direction. Okay. Positive Y is going up here. How many quadrants?
4.
Because the 2 axes, when we put them at 90 degrees, break the flat surface into four quarters, right? Which way is clockwise versus counterclockwise? So the positive is in the upper right hand corner, and then it increases going in a counterclockwise direction. Okay, that's important. That's going to come up later. In the order pairs, this is the x, this is the y. A comma b is the x comma y. Okay, I think this is okay. I'm not gonna go deeper there. The distance formula. Now, with this image, now can you tell me where does the distance formula come from? What does this shape look like? What kind of triangle? Right triangle. What's special about right triangles?
90 degrees.
They have a 90-degree angle. What's the main formula that they come from? Pythagorean theorem. Now, if I ask you, where does the distance formula come from? See that? Do you see it? Right. See, if this is a right triangle, you have these 3 points, P, Q, and R. If this were a right triangle, this would be your side A, this would be B, this would be C. Pythagorean theorem is what? A squared plus B squared equals C squared. So, if we want the distance between P and R, well, just solve for C. Well, okay, if we're looking here, say we want to find the distance, we want to solve for A. We want the distance from P to Q. What's changing along this? Are the x values changing or the y values changing? X, right? Because y here is 3, y here is 3. So the y is the same, but the x's are changing. From this point to the y-axis, what's this distance? 8, right? From the y-axis to this point, what's the x? What's the distance? What's the distance? 4, right? Absolute value of -4. That's okay. So this is 4, this is 8. What's the distance of 8? 12, right? Does that make sense? So that means this side is going to be 12. Okay? Similarly, what's from here to the x-axis is what? 3. From here, from the x-axis to this point is 2. So this total distance is 5. This is 12. This is 5. A squared plus B squared equals C squared. We can solve for the distance. That's where the distance formula comes from. Copy that. Keep moving. So I think they solve it. They keep going with the train of thought. We're going to have some fun today, hopefully. We can get some competition going. A little bit of healthy competition, not anything bad. So the distance between P and Q, we did that already. Right here. So the distance formula. So again, the discussion comes out of the Pythagorean theorem. You know, if we go to this between 2 points, we can always introduce a point like this, create a right triangle, right? Then A squared plus B squared equals C squared, the right triangle. So then we can quickly solve. So when you solve for C, you get this. Is this clear where this comes from? Remember, for A, remember this, we said x2 minus x1. We said this minus that. What's 8 minus -4? Double negative is a positive, so it becomes 8 plus 4, 12. So this minus that, that's where the 12 comes from, whatever we get. And the same thing here. Y2 minus y1. Okay? So, yeah, that's where the formula comes from. The distance formula comes out of the Pythagorean theorem. Okay? Let's keep going. This formula you should know. You want to commit this to memory. Now, we get on the exam. I may or may not give it to you right now. Just assume that I'm not going to give you this formula. You need to commit this to memory. And the reason I'm forcing you to commit this to memory is because you go to any other math class, they're going to expect you to know this. So that's why I was like, well, let me just go ahead and make sure that you all commit to it. Okay? I think it's fair to actually remember that, to know that. Don't remember it. But if you know the story behind where that formula comes from, if you know, oh, that comes out of the Pythagorean theorem, so let me just draw the picture, do the labels, fill it in, then you can derive the formula. In math, when instead of memorizing a whole bunch of formulas, if you know the formula is just the conclusion to the story. It's just the conclusion. So if you know the story, you can derive the formula. You don't have to remember a whole bunch of stuff. You know, so that's one of the techniques for synthesizing a lot of okay, so being able to derive formulas, know where the formulas are coming from. So again, distance formula, given 2 points, then the distance between any 2 points on the coordinate plane is going to be given by this formula. Okay? Questions, comments, or concerns? I'm going to pause for the cause right here.
I remember this.
It's an application of the Pythagorean theorem. It's an application. So because of the Pythagorean theorem, that's what it's from. But it's its own thing. Other questions? So we're going to move forward. All right. Find the distance. Let me do this one first. I think this isn't too bad. I mean, you have these 2 points, right? So we're using the formula. Whenever we use the formula, it's a good idea to write it down. So square root x2 minus x1 squared. I think this is okay. Now, when I have 2 points like this, I automatically just go ahead and label it. So I'm going to move the cursor there. I just automatically label it in the following way. I go x1, y1, x2, y2, just like that. But then when I go to plug it into the formula, it's super clear. What's x2? 3. What's x1? So minus what? It's going to be 3 minus 1. Negative 8. Is okay? So then you get the double negatives, so it's going to become 3 plus 8. So 11, so that's 121. What's y2? Right. And then minus what? 4. It's going to be what? Negative? Negative 6 is good. Negative 6 times negative 6 is?
No, 36.
Positive 36. So we got 36 and we got 121. I think that's 157.
Yes.
I guess I did it wrong. That's the only reason. I just remember. These are the notes that are in Moodle. Yeah. 121. So we said the negative 8. Sorry, x2. We said 3 minus negative 8. So it's 3 plus 8. Because it was a double negative. x2 minus x1. So 3 minus negative 8. So double negative. It's right here. You see it.
Okay, I lost where.
It's right here. Look. 3 minus negative 8. Double negative is positive. So 3 plus 8 is 11. 11 squared, 121.
No, I lost where that. Yeah, that is. On here.
Oh, it's not loading?
I mean, I know it's somewhere. Yeah, what you're working on right now.
The notes, if you go to Moodle, click on the box link, and it's in the notes section. The blank copies are, no, they're not there. If you go to Moodle and you scroll down, let me see if I can pull it up. Here. Hopefully it's loaded. So if we go to Moodle, I gotta take a test and I'll get that one momentarily. This is not really ours. So if you click on ours, scroll down and write unit. See what it says unit PowerPoint chapter 1, chapter 2. Okay. All right. So I think this is okay. Is it clear? Okay, let's keep going. So it says if the sides A, B, and C of a triangle satisfy the Pythagorean theorem, then the triangle has to be a right triangle. Where we have the legs, the shorter legs are going to be A and B, and the hypotenuse is going to be C. Is that okay? So if you have sides of a triangle and they satisfy the Pythagorean theorem, that means they have to be a right triangle. It has to be a right triangle.
So if it's not a right triangle.
Well, if it's not a right triangle, it's not going to satisfy the Pythagorean theorem. The Pythagorean theorem only applies for right triangles. Yeah, I think that's it. Okay, so then this question arises: are these points the vertices of a right triangle? Need 3 volunteers. 1, 2, 3. Right after it. Come on down. So the thing about opportunities do not go away. They go to what? Who's next? So if you're not quick on the draw, it's going to go to somebody else. Can we get the lights? Lights. Do not write on this. Pick your weapon. Somebody choose M. Somebody choose N. Somebody choose Q. So just write N. So just write your point on the board. Okay, we're going to have a little race. We're going to race. Okay? So do you have a copy of M? So M is going to be negative 2, 5. N is 12, 3. And Q is 10, negative 11. So each person choose 1 point. Okay? Now, the goal is, the question is, are these the vertices of a right triangle? Yes or no. But I need to see why. Okay? So you might be able to find the answer quick. You can work together. It's you guys versus me. So one person has 1 point of the triangle, another has another corner, and another has the third. Y'all work together. You might want to draw a graph paper, plot them. You know. The question is, are these the vertices of a right triangle? If they are the vertices of a right triangle, what should they satisfy? So draw the 3 points, create the triangle, label it ABC, find those distances with a distance formula, and then show that it satisfies or doesn't satisfy the diagonal thing. Does it make sense? Okay, so they're working together there. I will also open this to the floor. Okay, so if somebody on the floor can finish it out all the way and explain it to me, quickly, accurately, and walk us through it, so first person to get it on the floor has that as well. Okay, so I'm opening it up to the floor. So while everybody's working there, I'm going to work here. So matter of fact, everybody turn your tablets off. I don't want the tablets on because I know what's there, so I got to put them face down for right now. So no tablets, no laptops, put them away. So yeah, you can write. Is that how you're taking notes?
Yeah.
Use some paper. Just for right now. You can write it later. I just don't want you working in there because it's not fair. Flip it over. Needs to be face down. No excess yet. Okay. Just borrow a sheet of paper or pencil just for a moment. And if you want to, because I can't offer the opportunity to. So now the 3 original points are on the board. First person in the audience to do this properly. Phones away. Don't want to see any phones. Put them away. Put the phone away. Put it away. That's why I asked you to put it away. Okay. So that's open to the floor. Anybody, first person that gets it, I might be able to help you out. Okay. So that's there. I'm going to go here. I want to copy this. I want to create some paper because you're racing against me. So I gave them a little bit of a head start, and I'm coming with it. All right. So the 3 original points, they are. It should be. It's a brand new marker. Is it not
No,
right?
she's just saying for another color.
Oh, what color do you want?
Oh, yeah. Green.
Green? Light green or dark green?
Okay. So we are here. All right. This. So if m -2, 5, n 12, 3, q 10, -11. All right. So now let's set this up. You need another marker?
She said she wanted another color black.
I think
highlighted.
I should have. Here's one more.
See, my teacher's still on that.
Okay. So I have these 3 points. So let's start by. Really, I mean, we could graph it. But I'm not going to. I could. I'm going to do this one. Space. We need a formula. This one.
Yeah.
X2 minus
I think
X1.
this is X2 minus X2. I don't know what
Yeah, X2 minus X1.
Keep on. I mean, you can look it up. Okay, let's go like this. Let's go like this. Okay. You got it? You finished? No? It's a positive X, it's a positive Y. Let's plot these points. -2, 5.
I got mine.
You finished? Are these the vertices of a right triangle? I'm going to say it's done. So fix it. You made a mistake.
I don't know.
I'm saying you're wrong. I'm saying I made a mistake. Yeah. So fix it. Yeah. I mean, at least I think so. Like, because that's what the result was. Huh? What were your three sides? What are the distances of each side?
Radical 200 for MN, radical 200 for MT, and then radical 400 for MT.
What's your last name? Did you look it up? Okay, that's good. That's good. Okay. No, it's fine. Because you said exactly what I needed to hear, so I was like, that's good. Because I kind of did something earlier, and the student just looked up and said, okay, come explain it. She just explained it. And I was like, couldn't get rid of it. But you said the right stuff. You were able to keep up, so that's fine. Okay, give me one moment. 10, negative 11. But can you help him on the board and help him finish? Okay, so then, now, and what if we went like this? And I'm just drawing a picture just to be thorough for presentation purposes. If I were really racing, I wouldn't have, I mean, drawing a picture helps, but I know I'm just finding the distance between all the things. So the distance formula between 2 points P and Q, x2 minus x1 squared plus y2 minus y1. Right? Yeah. Yeah.
14 squared.
We'll see, because this is kind of intentional. It's like it's heating up. I'm only having it on the electrical way, but it's kind of hard. Are we ready at the board? Okay. And that's why I had 3 people come up to the board. Because this is what you're really supposed to show. The distance between M and N is root 200. But let's see.
So a right angle triangle equals 400.
Wait, let's see the explanation. No, no, let's see the explanation. Let's see. No, I didn't box that because it's not there. Okay. Okay, so let's get started. Can who chose somebody? Let's kind of walk us through with the setup. What did you guys do?
So first we plotted it, then we did the distance formula for N and Q. We got 200. Well, square root of 200.
Okay.
Then Kiara did the distance for M and N.
Can you just walk us through what you did?
Okay, so the distance for M and N, you're going to get your x2, which is 12. You're going to put it right here. Then you're going to get your x1, which is negative 2. And you're going to put it right here, but negatives cancel out, so it's going to be a positive 2. So 12 plus 2 equals 14. 14 squared is 196. And you're going to do it to the y side. So y2 for n is 3. And then you're going to put it right here. Y1 for m is 5, but it's negative because it's subtracting. So it's negative 2, and you're going to square it. That's 4. So 196 plus 4 equals 200. Excuse me. Is there a quarter here of Christina Shadowing?
I think we didn't. Hello. Can you start an attendance? Okay. Yeah, that sounds good. So that was, and then what did you do?
I did Q.
You did the angle Q or the distance from Q or something?
I'm sorry.
MQ. Oh, the distance from MQ. Okay. It's a brief overview.
Yes. So x2 for Q is 10. x1 for M is negative 2. y2 for Q is negative 11. y1 for M is 5. So we plug it into the distance equation. So 10 minus minus 2, which makes it 10 plus 2. And 11 minus negative 11 minus 5. And put that together, gives us 12 squared plus negative 16 squared, which equals 144 plus 256. And put that together, and that goes to the square root of 4.
Then can you just like bring it all together, like the whole thing, like just a brief, like couple of seconds, like a brief summary of the whole strip.
So the answer that's always the largest is your hypotenuse, and the other two are your sides. So the hypotenuse equals the two sides added together. But since it's pretty much Pythagorean theorem, you're going to square everything. So radical 200 squared, 200, radical 200 squared, 200, added together is 400.
Okay, you actually said something that was a little off, but what you said, the idea was right. At one point you said the two smallest added is the larger. That's another concept that's actually about to come up. But then you came back and you fixed it. You said a squared, you said the whole a squared is b squared is c squared, and that's fine. And those are the properties of the right triangle. Okay, so riddle me this. Say this is the shorter leg, right? Say it was a distance of 3, right? Say the other shorter leg had a distance of 5, right? What does so if you have this point here and this point here, what does this distance have to be? I'm trying to think of how to pose the question. So say this is 3, the shorter distance, and then the next distance is 5. Those add up to what? 8. 8, right? Now look at the distance from on the outside. Say that were equal to 8. What's the concept that's going on? If the distance from here to here is indeed 8, what does that mean about these 3 points? That they are on the same one. So say this is 3. The shorter one is 3. The middle one is 5. So together they make 8. Now if you take the outside endpoints, and that distance is also 8, what does that mean about these 3 points? That they are on the same. Close. What does this mean? What am I trying to do? So.
Yeah, keep drawing.
Let me see. So say this is 1, this is the other, right? In order for the total distance to be 8, what would happen if it was larger than 8? Yeah. The whole point is I'm getting at that they're collinear. So yeah, if this is 3 and this is 5 and the total distance is 8, if the total distance were 9, can they be on the same line? Well, they can, but what's the problem? I don't think so. No, because if it was larger than 9 and you're talking about these 3 points, it's going to do what? It's going to buckle, right? They won't match. So in order, no, it's going to spread out. Anyway, is the only way for them to be on the same line, they have the distance here plus the distance here has to equal 8. If it's anything other than 8, it's not going to be collinear. Because if it's less, it's going to buckle. If it's larger, then it will kind of separate. You know what I'm saying? So it wouldn't be the same thing. That's what we're actually about to explore right now. Let me give everybody here credit. I just borrowed people's stuff. I don't know. Okay, let me get some names. Actually, is the attendance? Let me say Herb Palmer. Well,
Kinsey.
Okay. What's the last one? Ringer?
No, this
What's the last one? What's your last name? Okay, so I will make a note of that. Attendance should be coming around. Make sure everybody's name is on attendance. I will log that and include extra credit when I take attendance. So yeah, that, explanation is what it is. Can we hit the lights again? Yeah. Okay. So I went on and made a copy of what they did, and so yeah, that's the gist of it. So the original question goes, not that one. The original question is here. It asks us, are these 3 points the vertices of a right triangle? In order for them to be the vertices of the right triangle, we need to verify that a squared plus b squared equals c squared. The sum of the squares of the 2 shorter legs equals the square of the larger leg. Okay? So we plotted them to get a sense of orientation, and then we labeled them, and then we found the distance between all 3 sets of points, right? So long story short, we had to do the distance formula 3 times. That's why I chose 3 people. That way they can divvy up the work. Where is it? I have one. There it is. Copy. So we had to do the distance formula 3 times. Again, the suggestion is every time we use a formula, write it down. Writing the formula will help you to remember it. So distance here, we got root 200. We did it again, we got root 200. And then when we did the third one, we got root 400. And indeed, those indeed satisfy. That's why I was saying check it again. Yeah, so go ahead.
So even though you have 3 equations or 3 sets of numbers, you only do the ones that are the smallest. So
What,
like Q.
you just want to verify that a squared plus b squared equals c squared. So it just happened to be the case that this was root 200. This one just happened to also be root 200, and this just happened to be root 400. What kind of triangle is this? It's right. It is a right triangle, but it's also what? It's also a isosceles because
Because
2 sides. Did that answer your question?
No.
What was your question again?
I'm saying like he did Q and M, but there's 3 points. There's Q and M.
Yeah. So when you find it, so we got our 3 points. M, N, and Q, right? We plotted that point. We plotted that point. We plotted that point, right? So then the 3 points, when you connect them, it'll make a triangle, right? So we want to verify that this triangle that's made by those 3 points, that it makes a right triangle. So we verify that it satisfies Pythagorean theorem, this, right? So then, to find the distance between these 2 points, if we want the distance from M to N, we plug it into the distance formula. That'll give us A. If we want the distance from N to Q, which is our B, we plug it into the distance formula. We just happen to get the same thing, same answer. It's not always going to be like that. We got the same answer because it just happened to be an isosceles triangle. Okay. So then if we want the hypotenuse, we want m to q right here. This is m to q. Plug it into the distance formula. Then verify that those results satisfy a squared plus b squared equals c squared. We got a true statement. This is a true statement. That's why it's yes. These are the vertices of the right triangle. Does that make sense?
Yeah.
Any other questions? Okay.
I understand how to actually do it.
Yeah, that's how this whole class is. Like the whole thing is literally what you just said. That's what the whole thing is. But it's just that we don't have time in class to go through the homework. That's the challenge. Like it takes about 3 or 4 hours every day doing this stuff. And it's very evident as a professor when your math students are not doing homework because they have questions over stuff that is super simple. That's why we'd be so eccentric and frustrated because it's like, come on, I know you haven't been practicing. Well, it's simple, but it's not easy. It's simple, but it's not easy. Simple because when you really think about it, you're like, oh, this is simple. But then it's not easy because it is information overload. We are doing, I think, a semester's worth of work in a quarter. So we have to work. It's already kind of a challenge in a semester. But now we're jamming it into a quarter. So that's why we have like this kind of thing with the live streaming and, you know, and some other kind of things I plan on doing to help. But those things that are offered for help are only going to help if you've honestly been pushing. If you push, then when I help, it'll be easy. But if you don't push and I help, it's going to be fruitless. I promise you. So you just kind of have to do your best to push, do as much of the work as you can, synthesize it as best you can. Then when it comes time for the exam, it should be really light. It should be. But I know the challenge is really a discussion on time management. That's what this is really about. Anyway, but no hard feelings on my end. I'm just trying to help as many people as I can. Questions, comments, and concerns before I go forward? Okay. So yeah, I think they say the same thing that we did. So that is what it is. So again, now if something were like this to pop up on an exam, especially if it was free response, this is the kind of work I'm really looking for. Now, I would say it is safe to anticipate multiple choice, anywhere from 15 to 20 questions. Okay? I would say anticipate something like that, maybe a couple of bonus, so that you can kind of work that. And, you know, multiple choices is a little different than free response. My multiple choice typically is all or nothing. I don't give partial credit for multiple choice. That's why I throw a couple of extra questions on the exam as extra credit. If it was free response, then there would be partial credit. But multiple choice, I typically do not do partial credit. Okay? So there will be a few, I would say anticipate a few extra questions. You know, you think about what kind of score you want to make and how many you need to get right in order to make your desired score. And you probably should do a little more just in case, you know, you make a mistake. But anywhere from 15 to 20 multiple choice questions with a couple of bonus. Okay? All right. But yeah, so it requires that kind of work. It's just daunting. And I get it, but this is the challenge that's before us. This is what we have to face. And it's okay. So this is what I was trying to get at with the whole collinear thing. It says that we can tell if 3 points are collinear, that is, that they lie on a straight line or they lie on the same line, using a similar procedure. It says that 3 points are collinear if the sum of the distance between the two pair of points is equal to the distance between the last pair of points. So again, that's why I had this image, and then this one, right? And then, so this shorter one plus this middle one equals the total distance. That's what it means for them to be collinear. But if they're not equal, like if that total distance is shorter, then it should buckle into a triangle. If it's larger, then it's no longer like 3 points. Something's not going to match up. Because you see, this one is actually going to be larger than short. So let's see if we can see this in action. The time, I haven't been recording the audio there, so I'm not going to worry about that right this second. This looks good. It looks healthy. It's going, can I see the time? 44. Okay, that's fine. That's right on the money. So we'll let that be. All right, so let's see this in action. The question is, are these 3 points collinear? So long story short, we have to do the distance formula again 3 times. So when we find the distance between P and Q, we get 3 root 10. When we find the distance between Q and R, we get 2 root 10. So in order for these 3 points, P, Q, and R, to be collinear, then the distance between PR should be what? 5 root 10. What's 3 root 10 plus 2 root 10? Is indeed root 5 root 10. So you add these like terms. To add radicals, they have to have the same index and the same radicand. Then we can add on we combine them similar to the way we do like terms. That's what I was trying to say. And I'm talking about it. But again, to add radicals, we have to have this, not only have the same index. What's the index on this 3 root 10? Is the index is an implied 2 right here, so it's square root. If it was cube root, there'd be implied, well, there'd be 3, right? So the index is 2, and what's the radicand? 10. What's the index? 2. What's the radicand? So we can add those together. These are like terms. We just combine like terms. So 3 plus 2 is indeed 5. So then that's the stipulation that we need for them to be collinear. Collinear, yeah. So we verify that. So the midpoint formula. Okay, we have this formula. You need to know this formula as well. The midpoint formula goes x1 plus x2 over 2, comma y1 plus y2 over 2. So given 2 points, and we want a point that's halfway between those two, use this formula. Now riddle me this. If I had 7 students' papers, the grades, right? I have 7 students in the class. I add up all of their grades and I divide by 7. What technique is that called? Yes, that's exactly what it is. So when you say, like we have 5 objects, we add up those 5 numbers and divide by 5, that's taking the mean or the average. So what is this saying? Take the average of your x's, comma average of your y's. So the midpoint formula is nothing but average of the x's, comma average of the y's. Or x1 plus x2 over 2, comma y1 plus y2 over 2. Okay, let's keep going. All right, we got the solution there, and that's fine. Coordinates of the midpoint of the segment. Okay, we have these endpoints. Again, what's 8 plus a negative 6? 2 divided by 2 is indeed. Okay. What's negative 4 plus 1 is? Negative 3 divided by 2 is negative 3 over 2. Okay, so it checks out. Let's look forward. Now this one says use the midpoint formula to answer this question. It says find the coordinates of the other endpoint Q of a segment where one endpoint P is this and the midpoint is this. So if we were going to solve this, where do you think we would start? They gave us x1 and x1, y1. What else did they give us? What's x2 and what's y2?
X2 is 8.
They gave us what? They didn't give us x2, y2. They gave us the midpoint. So they gave us x1, y1, and they gave us the midpoint. What are we missing? We were missing x2 and y2. Did I say that right? Yes. Okay. So if you were going to solve something like this, what would you use? Midpoint formula. How does the midpoint formula go? That's okay. Any questions here? This is the midpoint formula, right? So let's plug in what we have. This is our x1, y1, right? But this is the midpoint. So this is the x coordinate of the midpoint. This is the y coordinate of the midpoint. So let's plug it in. So we got negative 6 plus, we don't have x2. We have 12 plus, we don't have y2. And the midpoint, the solution is 8, negative 2. Okay? Now, if we wanted to solve this, how is it that these two order pairs could be equal? How is it that this order pair is going to be equal to this order pair?
Set it to 0.
Not set it to 0.
But you can still divide.
Solve how? Well, I didn't hear what you said earlier. Solve what though? Like what do we have to do? There's one other little thing. For instance, if this is x, what should this be equal to? 8, right? You see that? This is the order pair. This is x comma y. X comma y. This x should equal this x. This y should equal this y. That makes sense? So we have 2 equations going on. 2 unknowns, 2 equations. Now we're ready to solve. Right here. See? The x equals 8, we get this answer. This one equals the y, we get this answer. So then our claim is that the other coordinate, this is the coordinate of Q. Okay. Do I need to kind of go back or redo? Or? So, okay, when we did the midpoint formula, we had the formula. They gave us x1, they gave us y1, and they gave us the x coordinate of the answer and the y coordinate of the answer. So we were missing something in the setup. We were missing the x2 and the y2. So in order for this to equal this, that means that this x value here has to equal 8. This y value here has to equal -2. We have two unknowns, we have two equations, so we can solve. We just solve each one independently. They're separate. So then we can verify this. We can take this Q, we can take the original P, and make it and verify that the midpoint is indeed the result that we started. Okay, but that was just a little bit backwards to see that. The following figure depicts how a graph might indicate the increase of revenue generated by fast food restaurants in the United States from about 70 billion in 1990 to about 165 billion in 2010. Use the midpoint formula and the two given points to estimate the revenue of the fast food restaurants in 2000 and compare it to the actual figure. Okay? So we have this figure, right? It's telling us about revenue for fast food in the U.S. from 1990 to 2010, right? So they want us to find out about the year 2000. So how do we get this? How do we get this? What formula? Midpoint. Is that okay? So if we're going to use the midpoint formula here, so halfway between here, 1990 and 2010 is the year 2000. So then what about the y's? What are we going to do? Yeah, average. So we're going to say what plus what? 69.8 plus this, divided by 2, whatever answer we get, that's going to be the average. Okay, I think that's okay. So midpoint formula, I think we're okay with the midpoint formula. Average of the x's, average of the y's. We get this result. We see our estimate of 117.3 billion, which is greater than the actual figure of 107.1 billion. So when the actual record on file was 107.1 billion for the year 2000, but using this formula, this is an approximation. It's close. It's close to the actual. Yeah, it's not going to be exact. It's just going to be close. Yeah. Okay. All right. Let's keep going. We still got a few slides to go. Oh, order pairs. So if I were to say, give me a set of ordered pairs, if this is the equation, how would you generate, like if you were going to make a table, what would you do?
Start at 4.
Okay, I think you're thinking of graphing. If you're thinking about graphing, where would you start with the graph? Long story short. What's the highest degree here? 1. So what kind of graph are we anticipating? A straight line, because the highest degree is a 1. If the highest degree were 2, what kind of graph? Parabola. What about 3? Like an S kind of thing. Yeah. These are polynomials. So if this is going to be a straight line, what does the -1 tell us? To start. This is the y-intercept, and what does the 4 tell us? Slope. Slope is 1. Slope is 1. So on the y-axis, we would start at -1. Then we go up 4 and right 1. That's another thing. What's another way? So to plot a line, we need at least 2 what? Points. What's another quick 2 points that we can find in the degree? Yeah, that's what we did. That's what we were doing before. Well, that's another technique to create a table. Or find the x and y intercepts, right? So when we start doing intercepts, my suggestion is to do the y-intercept first, because typically the y-intercept is a lot easier than the x-intercept, usually. So let's see, for instance, if we do the y-intercept, what do? We set what? X is 0, right? So when x is 0, what's the y-intercept? You get a 1, right? 0 minus 1 is 1. Okay. So that's the y-intercept. The x-intercept, what do? We set
Y to 0.
Set y to 0. For the x-intercept, we set y to 0. So if we set this to 0, what happens? Add 1, and then
Divide by 4.
what do we get? See how it's a little bit more challenging. Now, when you start going further, they get a little bit more kooky, because then you have to factor, and all these other techniques come out for the x-intercept. But now we got intercepts. We've made a table of points. We use the slope-intercept form. We talked about this at least on 3 different levels on how to graph it. But here we would just kind of getting a set of ordered pairs. We would choose any x that we want, find the corresponding y. Choose any x that we want, find the corresponding y. So all we were doing here was creating a set of ordered pairs, a set of solutions for this. So that they were basically saying choose an x, find the corresponding y. Here they asked us to find a set of ordered pairs. So which would be easier to choose at random, the y or the x in this case?
The y.
Well, let's see. If y were if y were 4, right? If y were 4, what would happen? Then you get what, 3? And then what's the square root of 3? It says it's an irrational, so you have to do it. So let's try x. Now, let's say if we choose something for x. Like say we chose, let's choose 4 again, right? If this is 4, how are we gonna get the y? What do we do? Square both sides. So then it would become what? 16, right? 4 and 16. And then what? Plus 1, right? What? 17. So then when x is 4, y is 17. That one was good. We can do others like that. I know it was a lot, because we're doing it all in the head. I'm just not writing it out. But this one is easier to choose values of x because of the way it's situated. If it were y equals the square root of x, it would have been whatever's on the outside in this case would have been easier to choose. So we chose value for x here. We find the corresponding y. This one was easier to do that way. Let's look at another one. So this is a table. Oh, so they solve for x. I think no, this is different. But yeah, so creating a table. I think you know how to choose values of x, find the corresponding y. That's all that we're doing. Okay, so then we're just looking at ordered pairs. Graphing an equation by plotting points. So if we graph an equation, first you might want to find the x and y intercept. Again, probably the y intercept first, and then the x intercept. Find as many additional ordered pairs as needed. So a few additional points. The more points you have in your graph, the more accurate it will be. Plot the ordered pairs from step 1 and 2. Join the points with smooth curve or line. Let's just see it in action. Graph this. I think we did this one already, right? Well, we didn't graph it, but if we have 2 points. So for a line, we only need 2 points, right? We went over several ways to get 2 points here and just connect with the straight line. Let's see how they do it. So I think they started with the x and y intercept. If we're going to do the x intercept, what do? Set y to 0, so we get our x intercept. To do the y intercept, we set x to 0. Okay, we got our y intercept. So we got our x and y intercept. I think we find a few additional points. Okay, so we choose an x value, find the corresponding y. It chose a y value, find the corresponding x. So we just got a few additional points. Then we plot all of these. If it's linear, all of these points should lie on the same line. Axis is like x-axis and y-axis. Okay, so we plotted all the points connected with a straight line in this case. This one. Similar thing. I think we're about done. I think we can do all this. Okay. So that'll end this section. I need to take attendance and get ready for the next section. I'm going to pause the stream. Stop streaming.